In this video, we want to look at special angles. So the angles like 45 degrees, 60 degrees, and 30 degrees. So now we want to start with 45 degrees. So what we want to do actually here is to derive the sine, the tangent, the sine, and the cosine of 45 degrees. So we want to consider this isosceles triangle ABC. So we want to consider it. Now, by Pythagoras theorem, so we know that when we apply it, that this longest side, the line AC, will be nothing else but the square root of 2, or we call it root 2. So now, with this, now we can make some deductions. So we can deduce the tangent, the sine, and the cosine of 45 degrees. So we remember, I will start with tangent. So we are looking at tan 45 degrees now. So as usual, remember what tangent is. Tangent is opposite over adjacent. Remember that. So we are talking about the opposite to this angle, 45 degrees. So the side that is opposite to it is line AB. So we have line AB. So remember, there are two ways of indicating a line or the side or the length. So if we want to talk about length AB or line AB, we can denote it in this form. So we can write like this and put a dash on top of it. Okay. Or we can also put it like this. So this is also equal. So we can put it in a modulus sign. So we can write it like this. AB. So either way, we are still talking about the length AB or the line AB. That's the same thing. We go back here now. So the opposite is AB. That is the side that is opposite to angle 45 degrees. And the adjacent is line BC. So this is BC now. Okay. So this now will be equal to, so AB, we can see is 1, is of length 1. And BC is also of length 1. So this one will give us 1. So we have that tan 45 degrees is equals to 1. So we continue. Then we look at the sine of 45 degrees. So when we look at the sine of 45 degrees, we have sine 45 degrees. Again, we'll quickly recall the ratio is the same as the opposite. So we have the opposite over the hypotenuse. Okay, so this will now give us now. So the opposite we have already known is AB. So it's length AB. Okay. Then we go and look for the hypotenuse. So the hypotenuse from this triangle is the longest side, or the side facing the right angle, which is line AC. So this one will give us line AC. So we have AC here. Okay. Then AB is giving us 1, so it's of length 1. And AC is of length root 2, so we have 1 over root 2. Therefore, sine 45 degrees will give us 1 over root 2. Then finally, we look at the cosine of 45 degrees. So cosine, so we look at cos 45 degrees. So recall again what cosine is. Cosine is adjacent over hypotenuse. So we have adjacent over the hypotenuse. So this will give us, so the adjacent we have already known is line BC. So we have line BC. So over the hypotenuse, so the hypotenuse we know is AC. So this will be over length AC. Okay. So this will give us nothing else but the BC is 1 and the line AC is root 2. Again, we have gotten cos 45 degrees to be equal to 1 over root 2. So we have gotten these three important results. So we have gotten tan 45 degrees is equals to 1. Then we have that sine 45 degrees is equals to 1 over root 2. Again, cos 45 degrees is also 1 over root 2. So we take note of this. Maybe you copy it in your notebook. You always recall it. So in a couple of videos that will be coming up now, so we'll be looking at examples involving triangles with angle 45 degrees and see how we're going to have to evaluate this tangent, the cosine, and the sine of 45 degrees. Okay, so we have an example here. So we are still looking at the sine, tangent, and cosine of 45 degrees. So we want to look at this problem. So we have three of them. So let's consider I first. So let's look at I. In I, we are looking for the value of C. So C is unknown. Okay. So how do we handle this kind of situation? But we are given only one side. Okay. So we want to look at the trigonometry that will connect this 8 and C. So as you can see, the 8 is adjacent to this angle 45 degrees. And C is the hypotenuse. So we're going to look at the adjacent and the hypotenuse. And what connects them is cosine. Remember our acronomy, our SOHCAHTOA. So we always take note of that. So as you can see, we have the 8. 8 is the adjacent given to us. And C is the hypotenuse we are looking for. So to handle this now, we involve a cosine. So here we talk about the cos of 45 degrees. Like we said, this is equals to adjacent over hypotenuse. So the adjacent is 8. The hypotenuse is C. And from the last video, we're able to get that cos 45 degrees is the same thing as 1 over root 2. So cos 45 now will now give us 1 over root 2. And this is now equals to 8 over C. So the rest is easy. So the easy way to handle this is just to do a cross multiplication. So we can cross this way. So 1 can multiply C and 8 times can multiply root 2. So when multiply C, that will give us C. I will now have that 8 times root 2 is the same thing as 8 root 2. And this is what we expected to get. So C now is given as 8 root 2. So we can also go further. So we look at the second diagram. So we are going to II now. So we look at II. Again, we'll look at the size we are given. So we are given Y. Y is unknown. So we are looking at Y now. Then Y, remember, if you look at this triangle, Y is facing angle 45 degrees. So Y is the opposite now. So we have the opposite Y. Then 4 is also given. So this 4 is the hypotenuse. So we have the hypotenuse. So the trigonometric ratio that we combine the opposite and hypotenuse is sine. So we now work with sine. So here now we are looking at II. So we now talk about sine 45 degrees. And sine 45 degrees, or the sine, will give us opposite over hypotenuse. So the opposite is given as y. So we have y. And hypotenuse is given as 4. So we now have y over 4. Now, we also recall quickly that sine 45 degrees is given as 1 over root 2. So we now have here to be 1 over root 2 being equals to y over 4. Again, we do a cross multiplication. This is simple arithmetic. So we can have that we have y times 4 is 4. Multiply y times root 2. So this is what we have. But remember, we are looking for y. We are not looking for 4. So because 4 is a known value. So we are looking for y. So to handle this kind of situation, we just divide by root 2 in order to isolate y. So we have here 4 divided by root 2 being equals to y root 2 divided by root 2. And of course, when root 2 cancels root 2, you only be left with y there in the numerator. So we now have that 4 over root 2 is equals to y, which we can write by saying that y is the same thing as 4 over root 2. Okay, and that's what we have. Then finally, we look at the third case. So at this third triangle, again, we see what we have there. So we can see that 3 is facing angle 45 degrees. So 3 is the opposite. So the opposite is given. Then the next thing is to look at another side that we want to connect. So here, we can see that here involves the adjacent. So here, we are dealing with opposite and the adjacent. So tangent will play a role. So we use tangent to get our way out of this. So we now look at tan 45 degrees. So tan 45 degrees is opposite over adjacent, and here the opposite is 3. The adjacent is x, so we have 3 over x. Then we quickly recall that tan 45 degrees is given as 1. So we can write this as 1. So we have 1, which we can write as 1 over 1, which is the same thing as 1. So this is equals to 3 over x. So here we don't have much deal to do. So it's just a cross multiplication. And when that is done, we have 1 times x, which will now give us x. Then 1 times 3 will give us 3. So here in the third diagram, we have that x is equals to 3. So finally now, in the first diagram now, so we have that our c, is now given as 8 root 2. Then for the third triangle, what do we have? We have that our y is now given as 4 over root 2. And finally, in the third diagram, or the third triangle, we have that our x is given as 3. Okay, and that's how to go about it.